All right, so this question says a list of 6 functions is given below, and there they are. You can have a look at them. And the question says the functions above which could contain the point 5, 6 in ascending order of reference numbers are. So we're basically just looking at this and determining whether these functions could possibly have this point 5, 6 on them, or whether it's just impossible for them to go there. And you'll see in every case here there's another variable in there, typically a, although there's a b in the third one there. But there's an a in most of them, and in almost every case the a acts like a vertical stretch. So let's just take a look at the first one here. If we plug the point 5, 6 in, so 6 is equal to a times 5 times, well, 5 plus 3 is 8, and 5 minus 4 is 1. Is it possible that there's a value of a greater than 0 such that that would be true? And the answer is yeah, it's quite possible. I'm just going to divide. Basically, I know that my a here is going to be, just have to divide both sides. I'm going to get 6 over 40. Okay. Now, and I could do better than that, but there's really no point. I just want to know that it exists. For number 2, if I plug 6 in, 6 is equal to a over 5 minus 5, whoops, and then 5 plus 2. Well, here's my problem right there. If I plug 5 in, I'm going to get an undefined, I get an undefined result here because I've got division by 0. So no, that one won't work. Question 3, if I plug a 6 in, a sine of b times 5, is it possible that I could get a result here where a is greater than 10? Well, now that's an interesting question. So I tell you what, just for fun, what would it look like if I plugged 10 in? So if we made this 6 is equal to 10 multiplied by the sine of b times 5, I'll just make it 5b because that looks better. 5b. Well, this would mean that what I'm looking for here is some situation where the sine of 5 times b is equal to 0.6. Well, can sine be 0.6? Yeah, it totally could. In fact, that's right in the range there of values that sine can become. So absolutely it could. Now, it's depending on the value of b that you choose, that's going to change that value. And for example, if you let b equal 4, okay, if you let b equal 4, so that what we're dealing with here is the sine of 20 in there. So we've got 6 is equal to a sine of 20. It ends up that your a value is something like 17. So yeah, absolutely, that works. That's possible. Let's take a look at the next one here. 6 is equal to a square root of, well, 5 plus 3 is 8. Okay, so is it possible that I can get an a value out of this that's greater than 0? And yeah, for sure. A is going to be 6 divided by the square root of 8. Yes, I can simplify that, but I don't really need to because I can tell it's going to be positive. That's going to work. Let's take a look at the next one. 6 is equal to the log base a of 5. Now, this one, although the more comfortable you are with logarithms, the more obvious these sorts of relationships become. Remember that what we're looking for here is an a value that's possibly between 0 and 1. Now, that might not be clear right off the bat that whether that's true or not. So what we might want to do is convert this to exponential form. So a to the 6 is equal to 5. That doesn't really help here at this point here. I'm still not sure what's going on with a. So maybe what I'm going to do is to get a by itself, I will take the 6th root of both sides. And when you get that, when you do that, you're going to find that a is actually a value greater than 1. So it actually doesn't fit in that domain that we're looking for here between 0 and 1. So this one doesn't work. And now finally here, 6 is equal to a times 1/2 to the 5th. A little bit of simplifying here, that's going to give me 6 is equal to a times 1 over 32. And so, yeah, a is going to equal 6 times 32. That's greater than 0. That's going to work. So my answers here are going to be 1, 3, 4, and 6.